Okay, let's get out your notes for 6.3 ambiguous case problems. This is kind of a supplement to what we had before for notes. But before you start, and if you have your calculator by your side, I want you to go to mode and make sure your calculator is set on degrees, not on radians. If it's set on radians, this is not going to work out very well for you. Okay, so in our ambiguous case problems, it means that when we're solving a triangle, that means that there's going to be all angles, all sides solved for. If you're given an angle and two sides, there's a few possibilities that exist. There's actually 4 different cases that can happen. I'll just draw them all out first, and then I'll put in the text to support them. It's supposed to be a 90-degree triangle. Okay, so the way these triangles exist, we'll just call them case 1, and 2, 3, and 4. So in case what happens is that, let's say we're given an angle here, and we'll call this A, angle A and B, so we'll call this A. What happens is this length A here is too short, so if you try to calculate, you're going to get an error on the calculator. So here we can say that no triangle is formed. And there's no solution for this one. In our second one, what happens is we have our angle given here, opposite A, call this B, and it just so happens that this forms a right triangle. So here, a right triangle is formed. So there's going to be one solution. And to solve for it, you just have to use the trig ratios. Okay, now, in the third one, what's interesting here is that the length of this can be happening here, but because it's a little bit shorter, if you swung it this way, it could form a second triangle. So from here, it can form 2 possible triangles. So here we could have 2 triangles formed. So there's 2 solutions. This is what we call the ambiguous case. Okay, and in the fourth example, what happens is that this line segment is longer than this line segment, so you can only really form one triangle from this. So in this you have one triangle formed, and you're going to have one solution. Let's go through a couple of these cases to help you to understand how they work. So the first one here, this is the calculations you're going to see for it. Maybe not a bad idea to start by sketching it out first. So in this one, we'll just draw in a triangle. So just label just as A, B, and C. And we really can't tell whether something like this is ambiguous or not. Right at this point, A, point B, point C, A is 2, B is, sorry, A is 2, B is 6, A is 30 degrees. So we can solve this triangle. Now, this has the potential to be ambiguous because the side that's opposite the angle is less than the side, than the non-included side. So another way you can look at it is this, is you take side A and you divide it by side B, less than 1, it has the potential to be ambiguous. So that's how you'll know if you have to do a second set of calculations if this exists. So let's set it up with sine law. Over 6 sine b. Sine b is going to be equal to 6 sine 30 degrees, all divided by 2. Sine b is equal to 1.5. So you see a problem here already is that the sine functions were made with a unit circle, and the most it can go to is 1. So when you punch this into your calculator, you're going to get an error. So what this really means is that this line segment is so short in real life that no matter where you move it, it's never going to form on that triangle. Okay? So we can say no triangles form. So if we go back to the first page of notes, this is a case 1. Now, I'd like you to take a look at the ambiguous case and how it looks and how you need to solve it. So for the ambiguous case, again, we're just going to sketch it out. We have some information here. So I've got triangle ABC. Nowhere does it say it's a right triangle, so we're not going to draw on any right angles here. ABC, we know A is 30 degrees, A is 3, B is 4, whoops. But we see that because 3 is less than 4, or if we took the ratio, this could be ambiguous. So that's your hint. If this number across the angle is less than this measure here, then it has the potential to be ambiguous. All right, so let's set up sine law. So show the setup. Maybe one calculation step along the way is a good idea. Now, when we go second sine, 0.667, this now changes to an angle. So the sine has to change to angle, be at 41.8 degrees. Okay, so we know that this is 41.8. All three angles of a triangle have to add up to 180. So angle C is going to be equal to 180 minus 41.8 minus 30. And that's going to give us 108.2 degrees. Okay, last thing we have to do is figure out what side C is going to be here. So we're going to go C sine 108.2 degrees is equal to 3 sine 30 degrees. So C is going to be equal to 3 sine 108.2 divided by the sine of 30. And our lying segment is going to be equal to 5.7. Okay. Now all I want you to do here is kind of separate out your calculations. So let's say, well, because of what we've seen here, that this 3 across the angle is less than 4, is there a second solution? So we have to do a second set of calculations. Okay, so if we do shift this triangle over here, you're going to notice that if we move this line segment over to this line segment, now it's not really drawn proportionally, but this now becomes this angle, and this angle become the same. So it becomes an isosceles triangle, right? And an isosceles triangle, what happens is, if this angle over here at B is 41.8, it must mean that this is 41.8. This angle that I'm going to calculate in here, if this is a flat line of 180, all I'm going to do is I'm going to take 180 minus 41.8, and it's going to be the angle in the smaller triangle now. So from here I'm going to go, this new angle B is going to be equal to 180 minus 41.8. It's 138.2 that makes sense. It looks like it's a bigger angle. So that means that angle C is going to be equal to 180 minus 138.2 minus 30, which is this angle over here, and that's going to give us 11.8 degrees. So that's, at this point, we kind of know that it's working because we've got the three angles, and the last thing we have to figure out is what this new length here. This is still 4, this is still 3, but we just need to figure out the new length, and I'm going to have to create some space here. Okay, so just carrying on my calculations over here. Last thing, let's do another sine calculation. C over the sine of 11.8 is going to be equal to 3 over the sine of 30. C is going to be equal to 3 sine 11.8 all divided by the sine of 30. And my line segment C is going to be equal to 1.2. So this is case 3. Now, just for organizational sake, and you want to make sure you get all this stuff down, you probably want to put together some kind of chart on this page. So just need a little section here, just to make sure you haven't forgotten anything. Chart that looks like so. Do the angles first. We'll go angle A, angle B, angle C, and then line segment A, B, and C. This will be for triangle 1, this will be for triangle 2. Okay, let's pull down this information. So we know that angle A never changes, so that's going to remain at 30 degrees here, 30 degrees there. We know from our calculations that angle B, 41.8, and then angle C we calculate to be 108.2. Line segments, well, the 3 never changes, right? The 4 never changes. And then the C, this was 5.7. This was 1.2. Go back and look at the calculations. This for angles was 138.2 and 11.8. When this chart is full, you know you've got a complete ambiguous case. Okay? Flip over to the next page and just check check if you can do the ambiguous case. So this is ambiguous. Carry the calculations all the way through. Okay, so this is the complete solution for the check for the ambiguous case. Just stop the video and check your calculations and see if it's working okay. Okay, let's move on to our last one, and this is the case where you know right away it's not ambiguous because of the way that it's going to be drawn. So we put into this, and we see that we have our triangle set out here. So we can see that if we go ABC again, which isn't bad for when you're doing the ambiguous case, that this is 30 degrees, and A is 4, and this is 3. And because that ratio is greater than 1, this is not ambiguous. So you're only doing one calculation. Okay, so we'll start with sine law. Same pattern as before. So we calculate our angle B to be at 22 degrees. So our angle C is going to be equal to 180 minus 22 minus 30, and that's going to give us 128 degrees. Last thing we have to do is solve for side C. So C sine 128 is equal to 4 sine 30. I'll just solve for C here. So C is equal to 6.3. All angles, all sides done. So That's my one case for this one.